Good morning. The article that I chose for this presentation was from Khan Academy explaining the relevance of chemical bonding. Like all things, living things are made up of something. Living things are made up of atoms, yet those atoms aren't usually just floating around. They are interacting with one another. Atoms can be linked together by strong connections and arranged into molecules or crystals. Or they can create weak connections with other atoms that they come in contact with. Strong ties that hold together molecules, as well as weaker bonds that form connections, are necessary for the chemistry of our bodies and existence of life itself. But why do chemicals form? The basic answer is that atoms strive to achieve the most stable state possible. To achieve the most stable state possible, they want to have the lowest energy. If atoms don't have this arrangement, they'll want to reach it by either gaining, losing, or sharing electrons by bonds. Some atoms receive or lose an entire electron, or they can lose multiple electrons to become more stable. Atoms produce ions, or charged particles, when they do this. An electron, gain or loss, can fill an atom's outermost shell, making it more stable. The electron transfer occurs when one atom loses an electron or another atom obtains that electron that they lost. Electron transport between sodium and chlorine atoms is a good example of how to explain this. Sodium only has one electron in its outer electron shell. By giving away that one electron is easier and more beneficial than finding several additional electrons to fill that outer shell. As a result, sodium tends to lose its one electron, generating Na+. Chlorine has 7 electrons in its outer shell. So in this scenario, chlorine prefers to gain 1 electron rather than lose 7. So it usually will take the 1 electron that sodium gave away. Ionic bonds are created when 2 ions with opposing charges come together. To form sodium chloride, or known as table salt, positively charged sodium ions and negatively charged chlorine ions attract each other. Another way for atoms to become more stable is to share electrons rather than just losing or gaining them, forming covalent bonds. In the molecules of human beings, covalent bonds are more prevalent than ionic ones. Covalent bonds are classified into 2 types, polar and nonpolar. Electrons in a polar covalent bond are unequally shared by atoms and spend more time near to one atom than the other, because of the uneven distribution of electrons between the atoms of different elements. Slightly positive and slightly negative charges form in various sections of the molecule. Nonpolar covalent bonds develop when 2 atoms of the same element or atoms of different elements share electrons more or less evenly to create nonpolar covalent bonds. For example, the molecule oxygen is nonpolar because the electrons share evenly the 2 oxygen atoms in H2O. Strong and weak connections both play important roles in chemistry of our cells and bodies. Strong covalent bonds, for example, keep together the chemical building components that comprise a strand of DNA. However, weaker hydrogen bonds keep the strands of DNA double helix together. These weak links keep the DNA stable while also allowing it to be copied and used by the cell.